I welcome you for this presentation. In this presentation, we are going to discuss about mail security. This is the overview of this presentation, that is introduction to mail security, then pretty good privacy, then PGP operation with respect to authentication, confidentiality, and both authentication and confidentiality, then PGP operation with respect to compression, then PGP operation with respect to email compatibility, then the summary of the PGP operations, then PGP message format followed by the PGP key management. So what is the need for email security? Nowadays, everyone is using the email, and without email, we can't live nowadays, because every messages we are getting in or every information from the institute we are getting in through email. So email plays a vital role. Then how to secure our email? Because every day we are having our institute email address as well as we are having the personal email address. So how to secure our email? That is mail security. For that only we are studying this email security. This email is one of the most widely used and regarded network services. It is one of the services because it is providing the mail service, electronic mail service it is providing. And currently the message contents are not secure because we have to inspect either in transit or by suitably privileged users on destination system. Because nowadays we are getting so many mails from the attackers, even not by just they are showing that we are receiving a mail from the director sir, but it is not actually from the director sir, because earlier in the beginning of this semester we have some awareness mail from our institute that if you are getting some unwanted or bogus mail from any one of them by giving the name of the director or registrar or the faculty members, don't you just check once, then only you have to believe whether the information is correct or not. So some minor changes they are giving in, and they are just acting like they are the original person, that is they are from our institute. They are just giving a show that they are the original person. They are just mimicking that they are the original person and giving some bogus information to us in order to collect all our useful information. For that only they are pretending like they are the actual or original user, and they are sending some mail. So how to avoid those things, or how to secure our mail? For that, what we have to do, that only we are going to see in this presentation. So the email security enhancements include the confidentiality with respect to confidentiality. That is not all the messages we can show to every person, because sometimes we are having some sensitive information. Those things we don't show it to others. So some confidential information we have to protect it from the disclosure from unauthorized person. Now from everyone actually. So even you don't give your mail password to your friends or relatives like that, because there may be a possibility of misusing your email. So always we have to secure our email. Whatever aspects we know, at least we have to secure in that way. Don't disclose your password to anyone, or don't make all the time the password a saved password. Whether you have to remember your password or not, it is always asked in the mobile phones. So if you are always your mail is open, means if you lost your phone, unfortunately you are not giving any password or pattern in your mobile phone. So whoever is getting your mobile phone, they can easily access your mail. They can send any mails to anyone by having your name. So always don't give all remember password like things, don't always give. Always you have to remember your password and you have to type. Don't make the system to remember the password. That is also one type. The attacker can easily get your password and they can directly enter your mail ID, and they can send some mails to other persons mimicking that they are you, like that. So we have to always secure our email. The another thing is authentication. That is the sender of the message. That only I told you. Sometimes we tell that I didn't send, we deny, not repudiate. We have to perform all those things. I didn't send the mail like that, but the mail was received from your mail ID. How it is possible? Someone else knows your mail password, or someone else hack your system and utilize your mail. Then only it is possible. But we are denying that I didn't send the mail, or sometimes we are denying that I didn't receive the mail, because some third party is routed to your mail. Whatever the mails coming into your mail, that is gone to some other's mail because something is routed. So the authentication, we have to always have the authentication also. That is the sender of the message we need to know. Then the message integrity, that is protection from modification. Whatever the mail you are sending to others, if in between in the communication network someone is getting your mail and they are modifying something and again they are resending, means in that case also we have to secure it. Those things we have to avoid. How to avoid all those things? What are the security measures we are following in order to have the or secure the email? Those things only we are going to see. Next is not repudiation of origin, that is protection by denial by sender. That only I didn't send the mail, how you receive my mail, because I didn't send. Many cases it happens because sometimes we save our password and if the person is sometimes earlier he or she was your friend, but now if he or she becomes your enemy, in such cases they will use to send some bogus message from your mail ID. Such cases will happen. So always we have to secure our mail. That is the main thing. For that, what we are going to do, or in the system as such, what are the things, methodologies available, that only we are going to see here. First one is pretty good privacy. Mainly here we are mainly S-MIME is also there, but based on your syllabus, here we are going to discuss only pretty good privacy. This is a widely used de facto secure mail. It is developed by Phil Zimmerman. Here we are selecting best available crypto algorithms to use. Here in the pretty good privacy, many crypto algorithms are used to secure the mail, and it is integrated into a single program or Unix, PC, Macintosh or other systems. It is originally free. Now also have commercial versions are available now for this pretty good privacy. So coming to the pretty good privacy operation with respect to authentication, what we are doing, that is we are to the sender creates a message, make SHA-160 bit not 11 SHA-1 160 bit hash of message, then attach the RSA signed hash to the message, then receiver decrypts and recovers the hash code, receiver verifies received messages. So whatever authentication, with respect to authentication we have to use some hash algorithm. We have studied the SHA-1. So this secure hash algorithm 1 is used, that is 160-bit secure hash algorithm 1 is used to perform or secure the email. How it is working means, here you see the message, the hash of the message is generated, then encryption process is performed with respect to private key of A, then the message plus the encrypted message is concatenated, that is formed as Z, that is sent to the destination. So here the destination, the receiver is receiving the Z. So they are just from the Z, they are just getting the message as well as encrypted form of the message. That is using the private key of A and the H of M, hash of the message they are getting in. Then they are applying a decryption function using the public key of A. Then they are comparing, they are just creating the hash of the message plus whatever the encrypted message they have get, that was decrypted and that message was compared with the hash of the message. Finally, they are telling that it is authenticated. If both the hash value as well as the decrypted value both are same, then we are by comparing they are telling both are same. So it is a valid content. If it is not same, then they have to find that some attacker plays something. So we have to reject it and it is not the valid message. So this is PGP operation with respect to authentication. Next is PGP operation with respect to confidentiality. Here the sender forms a 128-bit random session key. Sender is forming the session key, then encrypts the message with the random session key, then receiver decrypts that, then attaches the session key encrypted with the RSA crypto system. Then receiver decrypts and recovers the session key, and the session key is used to decrypt the message. See here, the encrypted message, the session key is used, and here only the RSA crypto system is used. Then they are sending it and the receiver is decrypting and recovering the session key. And using the session key only, the receiver is decrypting message. So here is set, then is set inverse, the receiver obtained. Finally, they are the receiver is getting the message M. Next is PGP operation with respect to confidentiality and authentication. So in confidentiality and authentication, in the earlier slides we have seen separately how the authentication is applied to PGP and how confidentiality is applied to PGP. So combining both, so it can use both services on the same message. That is, we are creating the signature and attaching the message, then encrypting both message as well as signature, because signature is to have the authentication purpose. Then here we are attaching RSA as well as LGML or RSA or LGML encrypted session key. So both the things we are so both confidentiality and authentication we are using. That is, we are securing the message as well as we are giving the signature also, so that it is providing both confidentiality and authentication. So this is the combination of both authentication as well as confidentiality. Next is PGP operation with respect to compression. By default, this pretty good privacy comes after signing but before encrypting. So we are here, we are just performing the compression operation. So before, how we are compressing the message means after signing the message, we are performing the compression operation, but before encrypting, we have to compress it. Then we can store uncompressed message and signature for later verification. And because compression is a non-deterministic thing, we are just storing the uncompressed message and signature for the later verification. And it uses the SIP compression algorithm. It is one compression algorithm used for PGP operation. And coming to the compatibility of this PGP operation, here when using this PGP, we have the binary data to send, that is the encrypted message. However, this email was designed only for the text only, but PGP must encode the raw binary data into printable ASCII characters, and it uses the radix 64 algorithm, that is, it maps 3 bytes to 4 printable characters. And it also appends the cyclic redundancy check also in order to verify whether it is compatible or not. For that only the cyclic redundancy check is included, appended. And it also segments messages if it is too big. So some size criteria is there. So we have to segment the message, then only we have to apply the appropriate methodology in that if the size of the message is too big. Otherwise, directly for the whole message, we can use the same methodology, same operation. This is the operation summary. That is, we are just giving a file as input, then whether we are checking that any signature is required or not. If signature is required, then we are generating the signature. If it is not required, then we are compressing it. In the compression operation, we have seen the compression is performed after the signature as well as before the encryption. So see here, after signature, if it is required or not, the compression operation is performed. Then confidentiality required means only we have to perform the encryption process. So here confidentiality, if it is required, yes, we have to encrypt it using any of the public key crypto systems. And if it is no, then we have to convert to radix 64, that is X6 or 64X. So this is a generic transmission diagram from A to B. If you are sending a message from A to B, this is the operations performed in the sender side. Then in the receiver side, the receiver received this radix 64, a message equal to R64 of X. So convert from radix 64, so X equal to R64 D inverse of X. Suppose the reverse operation is performed here. Always the receiver has to perform the reverse operation. So first we have to check confidentiality required. Yes means we have to decrypt it. If it is no, we have to decompress it. Here see opposite of that. Then we have to check whether signature is required. If it is required, then strip signature from X and verify the signature. If it is not required, directly we are getting the file. So this is the overall operation of the PGP, both in the sender as well as in the receiver side. So coming to the PGP session keys, we need a session key for each message of varying size. That is 56-bit DES is required, then 56-bit DES, then 128-bit for cast or idea not yet discussed, and 168-bit for triple DES. And generated using ANSI X 1.12.17 mode, uses the random inputs taken from the previous users and from keystroke timing of the user. So here how they are creating the session key. We know the key means it is a random generation number, random number only, we know that. So we know the methodologies for generating the random number. If it is a true random number, we are just creating the number based on the entropy sources. That is the physical component of a computer, some physical components of the computer here. So here how we are generating the random inputs from previous users or from keystroke timing. Based on some of the physical equipment of the computer only, we are just generating the random key, a random number for the session key used in PGP. Next, PGP public as well as private keys. We have many public private keys may be in use, and we need to identify which is actually used to encrypt the session key in the message. So we have to send a full public key with every message, but this is inefficient. Rather, we can use key identifier based on the key that is at least that is the least significant 64 bits of the key we need to send. And if it is a very large, likely to be unique. Always the key, if it is all the each and every time, if it is a unique, then we are getting better security. If it is not unique, it is vulnerable to some type of attack. Also use the key IDs in signatures. In the public and private keys, the key IDs are also used in the signatures. Next, the PGP message format, how the message format is there, because we have seen a SIB algorithm, right? So what is the SIB compression algorithm? So here these forms the SIB. That is, the content is there. The session key component consists of key ID of recipients of public key, then session key. Here encryption process happens. Then the signature part, we are having the timestamp, then key ID of sender's public key, leading to octets of message digest. Then we are having the message digest. In the message digest, we need to perform MD5. We have to use or a SHA. You can use anything. You can use for the signature purpose. You can use any of the hashing algorithms. Then in the message, file name is there, timestamp is there, data is there. The SIP consists of timestamp as well as the signature as well as the message. The SIP consists of. Then encryption process also requires the signature as well as the message. The operation, coming to the operation, and whatever R64, the result of the encryption process is R64. So that contains the full content. So SIP contains only the signature as well as the message. Encryption part also signature as well as message. R64 operation consists of full part, the session key component, signature as well as the message. So this is the PGP message format. Next, coming to the PGP key rings, here we are having each PGP user as a pair of key rings. That is, the public key ring contains all the public keys of other PGP users known to this user, indexed by some key ID. Because in the signature also we have to specify the ID. And the private key rings contains the public or private keepers for this user, indexed by the key ID and encrypted key from the hashed passphrase. And security of the private keys depends on the passphrase security. And PGP key rings, private key ring format is like this: timestamp, then key ID, public key, encrypted private key, and user ID. And the public key ring looks like this: that is timestamp, key ID, then public key, owner trust, user ID, key legitimacy, signature, and signature trust. The star, the field, see here, key ID star is there. This field is used to index the table, because always the ID, for example, for each and everyone having the unique ID. So the ID is used to index your names and all. So here also, in order to index the tables, the ID plays a role. So only here a key ID, their star is there. These are about the PGP key rings format. Next, PGP message generation process. We have seen the passphrase, right? So here we are having the message M. Here we are generating the hash of that. So we are getting the message digest that is encrypted here, and we are sending both the message as well as the encrypted message to the private key ring. It is given. So here key ring, we are having the ID. IDA is there. Then the whatever the concatenated thing is also given here in the private key ring. Then we are getting the encrypted private key ring, that is decrypt. Here you see, from the passphrase, the hash of the passphrase is generated. Then we are getting this DC. Finally, here in the public key ring is also used here. Then it is passed to the signature plus message is passed to this EC. Then here you see encrypted signature plus message is concatenated with the EP. EP, how we are getting the ring session key is applied here, and the encryption process is performed with respect to the public key. Public key where we are getting from the public key ring. Finally, the encrypted message plus the key ID plus the encrypted signature plus message is concatenated, and it is given as output here. This is the message generation process. So in order to secure the mail, what we are doing is so many operations, so many cryptographic techniques are applied in order to secure the mail. So this is one way of securing the mail. Many different methodologies are available. So in the reception part, what we are doing is, see here, here also passphrase is there. The hash of the passphrase is generated. Here, whatever the things, receiver's ID, encrypted session key, three things are concatenated and given as output in the previous slide. So, message, receiver's key ID, encrypted session key, and encrypted message plus signature. So, each and everything are passed on to different things, and they are extracted, and we are getting finally the hash of the message is compared with whatever the DP, and if both are same, then we are telling that yes, the received mail is valid. Otherwise it is not valid. That is, some attackers did some works and all. We can easily guess from this if both the values are not same in some. So coming to the PGP key management, rather than laying on certificate authorities, in PGP every user is has own certificate authority. Each and every user is a certificate authority only here. So can sign keys for users they know directly, and they forms a web of trust, that is trust keys have signed, and they can trust keys others have signed if have a chain of signatures to them. Key ring includes trust indicators. Users can also revoke their keys. So this is one example for the PGP trust model. So the user of the message, that is email, so we are receiving many messages from n number of persons. So we are getting many messages from n number of persons. Those persons are getting n number of messages from any number of persons. See here, the question mark, unknown signatory. From where we got, we don't know. That is unknown signatory. X to Y means X is signed by Y. So here you see H to B. So H is signed by B and B is signed to U likewise. So keys owner. So keys owner partly trusted by you to sign keys. If it is a full shaded, then full shaded means keys owner is trusted by you to sign keys. And if it is a half shaded, see here this layer we are having half shaded. Keys owner is partly trusted by you to sign the keys, and it is a circle with a dot, then key is deemed legitimate by you. So this is one trust model. So here each and every users are acting as a certificate authority. So we are just giving the authorization to sign. So whether it is a partly permission or a fully trusted permission, or it is a legitimate thing, or no unknown signatory. So many different variants of the trust model is there. So from where we are getting the mail, based on that we can trust the mail. So this is one way of trusting the mail using this PGP. So in this presentation, we have discussed about the mail security with respect to pretty good privacy alone. So how the pretty good operations are happened with respect to authentication, confidentiality, both authentication and confidentiality. Then how compression function is used, that is after signature and before encryption process only we have to use the compression function. Then the email compatibility, then overall summary in the sender part, how the operations of PGP happens, and in the receiver part, what is the working principle we have seen, then message format and the key management. Here we have seen about a public key, private key, then session keys, then the key ring concept is also there. So we have seen how all the keys are managed in this pretty good privacy. Thank you.